Okay, so you missed lesson 3.2.2. We first talked about how when you've got a negative object and a positive object, they will definitely attract. And you've heard that before, opposites attract. A negative object and another negative object will repel. Charges that are alike will do that. And this is the one that threw people through a loop. A negative object and a neutral object will actually indeed attract. And if you really think about it, if you've got something negative and you're bringing it up to a neutral object which has positive and negative charges, all of a sudden, as this comes closer and closer and closer, something interesting happens. The positive charges kind of line up, the negative charges get pushed to the back. Will it be as attracted as, a totally negative object and a totally a positive object? No, but there will definitely be an attraction there because of this. A neutral object and a neutral object, though, for our purposes right now, will not do anything. And then in class, we rubbed 2 balloons into people's hair. And then, because both of those balloons accumulated a negative charge, when you try to bring them together, they actually don't want to go together and they were repelling each other. Again, because like charges will repel. So in this lab, we were actually studying a bunch of different liquids. And I'm going to write the formulas out for these because I think it makes it interesting. There's H2O. There's CH3COOH, acetic acid. There's isopropanol, which is CH3CH2CH2OH. There's mineral oil, which is a long chain of just carbons and hydrogens. And then there's hexane, which is C6H14. We'll look back at these at the end and see if we notice any patterns. So one of the things that we did in class was we had burettes that had liquids in them, and we allowed the liquid to stream out into a big bucket, and we brought a balloon close to the stream after we rubbed it in someone's hair. And what was interesting was many of the liquids, all of a sudden, it was like it was magic, they were attracted midstream over to the balloon. It's kind of freaky. And so we saw that happen with water, acetic acid, which is the same as vinegar, isopropanol, and hexane, no. Mineral oil is too thick for a burette. It'll clog it up because there's a tiny tip at the end. But for the record, it would also do nothing. Then we had little dropper bottles, and with each type of liquid, we actually put the drops on a piece of wax paper and studied them. And water is really fun because it completely beads up. So it was very round. Acetic acid was also pretty round. Isopropanol was somewhat round. I'll say roundish for these. But then mineral oil was pretty flat, and hexane was super flat. So now, looking back to these molecules, what did these all have that these two don't? And the answer is they all have oxygen. And we're going to talk about why that makes a difference. So which of these molecules appear to have a charge? The top 3, the ones that were attracted and the ones that were roundish. So water, acetic acid, and isopropanol. Why does water bend toward the balloon? Well, when you've got this negative charge here on the balloon, there must be something going on with the water molecules. they must have some sort of partial positive charge attracting them over. So let's really look at a water molecule. We talked a little bit in class about how in the last lesson, the homework question, when you build oxygen or a molecule with oxygen in Odyssey and you look at the what's called polarity map, you see oxygen turns all red. And that is indicating that there's a partial negative charge. So even though hydrogen and oxygen are sharing these electrons, oxygen is pretty greedy and it takes a little bit more of its fair share of the electron cloud. So if this were the electron cloud, more of it would be closer to oxygen. And in class I talked about how it's like you're sharing chips and salsa at a restaurant. Is it equally shared completely? Well, it really depends on who you're eating with, but probably not. And if there's someone that's really hungry, they're going to get more than their half of the chips and salsa. And so when oxygen steals a little bit more of the cloud, it gets a partial negative charge. This is the little symbol that means partial. Kind of looks like almost an 8. And these hydrogens don't have a full positive charge, but they both get a partial positive charge. So if I were to blow up a stream of water, this is very exaggerated, the hydrogens would point toward that balloon because they have that partial positive charge. So how would 5 water molecules want to line up? Well, they would not want to line up with a hydrogen next to another hydrogen because those would repel. So the hydrogen of one would be attracted to that partial negative of another oxygen. So if I were to draw all 5, I'm going to line up my hydrogens with my oxygens. Just to be complete, I am going to draw all 5. Plus it's good practice for that little partial symbol that's kind of weird to draw at first. Partial negatives are next to partial positives. It says the charged wand experiment, or in our case a balloon, provides evidence of molecules interacting with a charge. Not only do some of the molecules interact with the charge, but they also interact with other molecules. The interactive forces between molecules are called intermolecular forces, or intermolecular attractions. As part of the making sense discussion, we need to talk about polar and nonpolar molecules. So, polar molecules are when there is an unequal sharing of electrons. And a little bit of a longer definition of it. Go to this. A polar bond is a bond in which an atom on one side has a partial negative charge and the other side has a partial positive side. That's why they're called poles. Kind of like how there's a north and south pole. If you've got, let's go back to our water molecule. This side of the molecule has a partial negative charge and these hydrogen sides have a partial positive. And that's all due to that unequal sharing of electrons. But a nonpolar molecule has an equal sharing of electrons. So maybe you split up the chips and salsa when you get to the restaurant exactly. That would then be nonpolar. So looking at the longer definition, there are not opposite charges on opposite ends. So this would be like a hydrogen sharing with a hydrogen. Nobody's winning here. It's a tie. Sometimes too, a nonpolar molecule will have some element that's pulling to the right and something that's pulling to the left, and because this is linear, they cancel out. And a polar molecule is different from an ion because in an ion there is a complete charge, not a partial charge like we've been drawing these little weird symbols. So like an ion, example, fluorine. Fluorine typically has 7 valence electrons, but when it gets an extra one, it forms a complete negative charge, -1. That is an ion, so that is how it's different. When you're talking about polar and nonpolar, you're talking about an entire molecule, not a single atom. It says ammonia is polar. Name 2 other things that are probably true about ammonia. Well, we know that because it's polar, one side of the molecule has a partial positive charge, and one side of the molecule will have a partial negative charge. We might also guess that it probably has an oxygen in it, since a lot of these other molecules seem to have that too. Not always, but a lot of times. Let's take a look at the homework questions too. Why do you think water formed a bead on the surface of the whey boat, or the wax paper in our case, but the oil did not? Water molecules love each other, so rather than be with the wax paper, they would love to ball up, and they're attracted to one another, so they all just kind of form this pile in this bead. They're like, yay, we're attracted to each other. Something like hexane with just a bunch of carbons and hydrogens, blah, blah, blah. There's no partial charges, so they don't care about each other and they just flatten out on the paper. That's the reason why hexane does not bend in the direction of the balloon. There are no partial charges attracting them to the balloon. Knowing what you know about water, do you think it would be attracted to a negative or a positive object? Explain why and show a diagram of each. Well, let's show a negative object. If you had a negative object, a water molecule, just like it did with the balloon, would point its hydrogens toward it because those hydrogens have a partially positive charge, and the oxygen would be pushed away. But if you had a positive object, the opposite would happen. The oxygen would be attracted to that side, that positive box, and the hydrogens would be pushed away. Why do you think vegetable oil and water don't mix? Well, water molecules have charges and they attract each other. Oil doesn't, so they don't mix. Finally, there's a little bit of practice drawing some structures. I'm going to draw these following the method that I like to use, which is first draw all of the elements with their lonely electrons pointing at each other, and then connect the dots. So I can see there's going to be a bond here and here. Now to name the shapes, there's one central atom. It has 2 things attached and it has 2 lone pairs. So I can check back in my notes, or I can remember that that is going to be a bent shape. Even if I happen to draw it in a linear fashion, I should not name this molecule linear. Because of these lone pairs, they're all pushing in 3 dimensions and it will have a bent shape. C2H4. First I'm going to draw my 2 carbons, and I've got 4 hydrogens to work with, so I'm going to draw those first. I'm going to connect everything at least once and then see what happens. And I can see that I've got 2 lonely electrons still, so I need to make the 2 carbons into a double bond. Now there are 2 central atoms here. That is, atoms that are attached to more than one atom. This carbon and this carbon. They each have 3 things attached and 0 lone pairs. So that means each of them is going to have a trigonal planar shape. And the last question, pH 3, I've got 3 hydrogens to point at these lonely electrons here. I'm going to connect everything once. And since this has 3 atoms attached and 1 lone pair, the name for this one is going to be pyramidal.